So today we're going to talk about 3.1 and 4.1. Okay, 3.1 talks about basic concepts of probability and counting. There's some definitions that I need you to know, that I need you to have. So we're going to start off with those. Okay, first one is probability experiment. What does a probability experiment sound like it might be? An experiment where you measure stuff, right? So it's a trial through which specific results are obtained. A trial through which specific results are obtained. An outcome is the result of a single trial. Then there's a sample space. Sample space is the set of all possible outcomes. The set of all possible outcomes of what? I didn't know I needed any today. It's okay. The sample space is the set of all possible outcomes of what? The experiment, right? Okay? It's all the trials. And then the event, oh, if I spell it right, sorry about that. An event is a subset of the sample space. An event may contain one or more outcomes. Excuse me. A simple event is an event that consists of one outcome. Okay? The last definition for a while, we'll do some more definitions in a minute, but the last definition I want to talk about is a tree diagram. Chances are you've seen a tree diagram before. It's a visual display of the outcomes of a probability experiment. Okay? So I want you to see an example of this tree diagram though. Okay? So here's an example. An example is I flip a coin and I roll a die. Okay, I flip a coin and I roll a die. What's the outcomes possible if I flip a coin? Anyone? Heads or tails, right? So I can get either heads or I can get tails. What are the possible outcomes if I roll a die? 1 through 6, right? So I could have rolled a head when I flipped my coin. So I have 6 possibilities from there. which is a 1, a 2, a 3, a 4, a 5, and a 6. Or I could have flipped a tail when I flipped my coin. And I could have gotten a 1, a 2, a 3, a 4, a 5, or a 6. Right? These are all the possible outcomes of rolling, these are all the possible outcomes of rolling a die if I first flipped a head. These are all the outcomes of rolling a die if I first flip a tail. Okay? So how many total outcomes do I have possible in this particular experiment? 12, right? There's 12 possible outcomes. The first one is a head and a 1, a head and a 2, a head and a 3, a head and a 4, a head and a 5, and a head and a 6. You see that? Or I could have gotten a tail and a 1, tail and a 2, tail and a 3, tail and a 4, tail and a 5, or tail and a 6. And if you counted all these up, I would have 12 outcomes. So let me make sure you understand what a simple event is by using this tree diagram. Okay? If I toss a head and roll a 3, is that a simple event? Is that a single outcome? How many ways could I toss a head and roll a 3? One way, right there, right? But what about if I tossed a head and rolled an even number? Well, 1, 2, 3, right? That would be 3 possible outcomes. Is that a simple event? No, that's not a simple event. Okay? Any questions about that? I need to teach you about the fundamental counting principle. Now, hopefully you know by now that if I teach you something that starts off with the word fundamental, you know that's pretty darn important, right? Fundamental theorem of algebra says whatever my degree, my highest exponent is, that's how many solutions there should be, right? That's a pretty fundamental thing in algebra. It's a pretty important thing. So if it's a fundamental counting principle, pretty important. Okay? Here's what the fundamental counting principle says. If one event can occur in m ways, and a second event can occur in n ways, then the number of ways the two events can occur in sequence is m times n. This can extend to any number of events. In sequence. Okay? So if it's 3 events, it would be m times n times p or something like that, right? If it's 4 events, m times n times p times q. Does that make sense? Okay? So here's an example. I have 3 car manufacturers. trying to buy a car, I can choose between 3 types of car manufacturers. For example, Ford, Chevy, GM. Are there any other kind of car manufacturers? Yes, but maybe those are the 3 we're talking about. You okay with that? Okay. Because of the kind of car I want, I only have 2 types of size of car. Maybe because of my financial arrangement or something like that. I only have 2 sizes. Okay. And then I have 4 choices of colors. Fuchsia, neon green, bright yellow, or orange. Those are good colors for a car, right? No? Okay. So how many different ways do I have to choose a color if I have 3 car manufacturers to choose from, 2 sizes, and 4 choice of color? What does the fundamental counting principle say? 3 times 2 times 4. What is 3 times 2 times 4? What's 3 times 2? 6. What's 6 times 4? 24 ways to choose a car. Another example. I need to create an access code. Do you ever have to do that? Oh, like for your phone? Yeah, you do, right? Or have you ever gone on vacation and in your hotel room there was a safe? You can create your own access code for that. Okay. I want to create an access code. This access code only has four possibilities, right? It's a 4-number code. Okay. If it's a 4-number code, how many possible digits do I have to choose from? How about 10? Why 10? 0, right? Because of 0. So I can go from 0 to 9, so that gives me 10 digits to choose from. Right? Okay, what if I tell you my first example, my first problem is I can use each digit only once. How many possible choices do I have for the first digit? 10. How many do I have for the second digit? 9, 8, and 7, right? And what do I do with those numbers? I multiply them, right? That's what the fundamental counting principle says. 10 times 9 times 8 times 7 equals what? Don't you know that off the top of your head? Of course you do. 5,040. 5,040 what? Possible access codes, right? Possible access codes. That's a lot, right? Okay. Second possibility. Use each digit as many times as I want. I don't want to write that. Use each digit as many times as I want. What's possible for the first one? 10. Second one? 10. Third one? And fourth one? Equals? Thank you. Possible access codes. I can put this. Each digit can be repeated. That sounds better. What about each digit can be repeated, but the first digit can't be 0 or 1. I mean, is that a possibility in real life? Where it specifies what the first digit can be or not be? Oh yeah, area codes. Zip codes not so much, right? Because those start with 0 and go all the way to 0. If it, up in Maine or somewhere like that, those are zeros. Those start with zeros. Ours starts with a 7, right? But that's just how the United States was divided, right? But what about area codes? Can area codes start with 1? What's our area code? 325, right? It used to be 210, now it's 325. 806 is up by Amarillo. Those aren't even close. Zip codes are at least close, right? Nearby numbers. So how do they figure out area codes? Here's my best answer. I don't know. They just do. But I do know something about area codes. You can't start area codes with 1 or 0 because those are country codes when you're making phone calls. Okay? So I know that the area codes are 3 digits and we're talking about one with 4 digits, but this is not a question that's out of the scope of possibility. Okay? So what is the first one allowed to be then? There's 8 possibilities for it, right? And what about the next one? That's 10, that's 10, and that's 10. So what's that? 8,000. Good job. Possible access codes. You okay with that? All right. There are 3 types of probability. That's an H. I'm sorry for that H. Three types. Okay? The first type is classical. If I could spell that right. Sorry. It's also known as theoretical. And when I first learned it, I called it theoretical, so chances are I'm going to call it theoretical more often than I will classical. Just so you know. Okay? The definition of theoretical or classical probability is the probability of an event is the number of outcomes in event E divided by the total number of outcomes in the sample space. Okay? Classical probability or theoretical probability is the probability of E is the number of total outcomes in event E divided by the total number of outcomes in the sample space of event E. Okay? The second kind is empirical. Jiminy Christmas. I'm losing my mind. And it is called statistical probability. When I first learned this, we called this experimental probability. So if I say experimental probability, that's probably what I'm talking about. We talked about theoretical and experimental. Okay? It also has a formula. The probability of an event E is the frequency of event E divided by the total frequency, or F over N. Classical, empirical. Now, I know that I told you there are 3 types of probability. And I've got room for 2, but I really don't. I have one more. Oh, Jiminy Christmas, don't write that down. Subjective probability. We'll talk about that more in just a little while. Okay? You have that one? Subjective? So let's talk about classical first, okay? What's the definition of classical probability? Say it. So the number of outcomes total number of outcomes in the sample space, right? So let me give me some examples of that. We're going to roll a die. Example 1. Event A, we're going to call event A rolling a 3. Okay? Event A is rolling a 3. What is the probability of event A? Well, how many total outcomes are there to get a 3? How many ways can you roll a die and get a 3? 1. And how many total outcomes are there in the sample space? 6. Done. Now you might want to have this there also, because sometimes it wants your answer as a fraction and sometimes it wants it as a decimal. Okay? You'll be able to tell by how it's asking the question. If it says don't round, you know it wants it as a fraction. If it says round to the the 100th place or the 1000th place, you know how it wants the answer as a decimal. Okay? Okay, example number 2, event B. Event B is going to be rolling a 7. So the probability of event B, okay, how many ways can you roll a die and get a 7? It's a normal die, yeah. 0. And how many possible outcomes are there in the sample space? 6. So the probability is 0. Why is the probability 0? There's no 7s on a die, right? There's no 7s. Now, that's why you guys even asked and I clarified that it was a regular normal die, right? Okay, because that's important, because I got a die in my desk right now that has a 7 on it. Seven. That's a die, isn't it? It's a 20-sided die with a little thing out of it, but that's okay. Okay, but it has a 7, so we have to clarify that we're using a normal die, don't we? Okay. Event C. Rolling a number less than 5. So probability of event C is what? How many possible numbers are there less than 5? 4. Are you sure? Do we count 5? Why not? Oh, just less than. Okay, so 4 out of how many total outcomes in the sample space? 6. So that is, I tell you what, if you put this in the computer, it will tell you it's wrong. 2/3. If it says don't round, but if it says round to the thousandths, 0.667, right? You okay with that? Okay. Any questions on classical or theoretical probability? It's what happens in theory. Okay? Empirical or statistical probability? Sorry. probability of event is the frequency of E divided by total frequency, which is F over N. So what do you need in order to be able to do some empirical probability? You need some results, right? You need some values, you need some frequencies. So I'm going to tell you, we did a survey, and in the survey there were 5 possible responses: always, often, sometimes, rarely, or never. Those were the 5 possible responses. In this survey, 1,054 people said always, 613 said often, 417 said sometimes, 196 said rarely, and 171 said never. So I want to know the probability that we choose one of these surveys at random and it says always on my survey. Well, what's the frequency of always? And what's the total frequency? All those added together. So 2,451. Now, that's a perfectly fine example of the probability, right? Doesn't really mean anything to us until we look at the decimal. And that's 0.430, so almost half, right? Close to half. Any questions so far? Okay. What I need you to know about classical probability versus empirical probability is there's such thing as the law of large numbers. I don't want to write on the back. What am I doing? The law of large numbers. Anytime I'm doing theoretical probability or classical probability, have I touched a die? I haven't touched it at all, have I? I'm thinking about anything that could happen in the probability, right? When I'm doing empirical probability or statistical probability, we call it experimental probability. Have I touched a die? That's the only thing I've done, is sit there and rolled and rolled and rolled and rolled. I've experimented with the die, right? So the law of large numbers says, as an experiment, is repeated over and over, the empirical probability of an event approaches the theoretical probability. Of the event. If I roll a die and I get a 4 and I say, what is the experimental or the empirical probability that I get a 4? My answer is 1, isn't it? Because I wanted to get a 4 and I did get a 4. That means the probability is 1. Okay? But if I roll a 4 and I wanted to get a 3, what's my probability that I would get a 4? 0. Because I didn't get it. Okay? The empirical probability, because I'm doing it, right? But what is the theoretical probability that I'll get a 4? 1 out of 6, right? As I roll and roll and roll a die, and I'm recording every time what I get, the more that I do that, the closer and closer my empirical probability will get to 1/6, which is what my theoretical probability is. Does that make sense? Okay. last type of probability is subjective. Subjective probability results from intuition, educated guesses, or estimates. What, we're guessing and we're going to call that probability? You've heard it before. I promise you have. Somebody's gotten sick and they've gone to the hospital and the doctor says you have a 90% survival rate. This illness has a 90% survival rate. I think that you will have a 90% chance of surviving. Guys, how many times has the doctor studied this and recorded all the results and knows it's exactly 90%? He doesn't, does he? He knows from past experience, from past patients that he's had that have this kind of illness, that you have a pretty high possibility of being able to get through the treatment and getting well and living, right? So he says 90%. I don't want to talk about the other way because that's a little sad, right? But that happens as well, doesn't it? An economics person, that the name just left my head, I'm sorry. An economic guy, I'll say, okay? He can do a study of different companies and he can say, this company right here has a 25% chance of their employees going on strike. What? Because he studied thousands of companies and kept all the records and knows that in this situation, 25% of them go on strike? No, he's guessing. He's using an educated guess based on companies that he has studied before. Does that make sense? So subjective probability is just that. It's subjective. We think stuff is going to happen because of our intuition, because of educated guessing, and because of estimating. Okay? The range of probabilities rule. We've kind of talked about this already without exactly talking about it, okay? But the probability of an event E is between 0 and 1. Inclusive. It can be 0 and it can be 1. So mathematically it looks like this. 0 is less than or equal to the probability of that event is less than or equal to 1. So if you have a 0% chance of something happen, will it happen? No, it's impossible, right? If you have a 1% chance of, not percent, if you have a probability of 1 of something happening, will it happen? Certainty, right? With certainty, we know it's going to happen. What about a 50% chance? Is that going to happen? It can, right? It's kind of an even chance one way or the other. What about a 25% chance? Less likely, almost unlikely, right? But what about a 75% chance? That's pretty likely, isn't it? Okay. All right. Last thing in this section is called complementary events. Now, much to my dismay, this is not where we stand around and tell each other nice things about each other. Okay, because that would be fun, but that's not what the math is. Okay, a complementary event is the set of all outcomes in a sample space that are not included in event E. They're not included in event E. Okay? The complement of E is written like this. It's denoted as E complement and said as E prime. That's how we say it, E prime, according to your textbook, okay? You have to know that this is something that I studied in my master's classes, and a lot of times we said E complement, not E prime. So if I say E complement, please know what I'm saying. Okay, does that make sense? The complement of E. So E, let's say E is the number that we roll on the die is at least a 5. If E is the number is at least a 5, what is E complement? That's right. Less than 5. So E would look like this. Sorry, equals 5 and 6, right? Those are numbers that are at least 5. What would E complement or E prime look like? Does that make sense? Okay. What if I take the probability of E and add it to the probability of E complement or E prime? What should I get? Yeah. So the nice thing about that then is if I'm just trying to find the probability of an event, couldn't I take 1 and subtract the probability of its complement? Or better yet, if I'm trying to find the complement, the probability of the complement, couldn't I take 1 and subtract the probability of that event? A lot of times it'll tell you the probability of the event and it'll want the probability of the complement. You don't have to add up all the numbers for the complement. You can just say 1 minus the probability of that event. Okay? Does that make sense? Any questions about that? That's 3.1. It's a lot, isn't it? Okay? But we're not doing any more chapters in that section. No, any more sections in that chapter. Only section 1. Okay? Do you want to do 4 today or do you want to wait till tomorrow? Tomorrow. Gotcha. Okay? It's okay. I could do it in 3 minutes, just so you know. It's much shorter. Much shorter. Okay? You're welcome. Do you have any questions about any of the stuff that we talked about today? Okay, so I want you to work on your homework a little bit, and then if you do have questions, you can come and ask. Peace.